Now let's talk about the type system when we extend the simply typed lambda calculus with mutable references. But the crucial question is, what is the right form of typing judgment that we need in order to be able to type check, in particular, this location? So the question is, previously we used this typing judgment. Under typing context, the gamma expression E has a type A. And the goal now is to extend this typing judgment somehow so that we can decide the type of this location L. So apparently the current form, this typing judgment, is not sufficient because there is no way to get the type of this location L. So we have to add something new here to extend the typing judgment. And the question is, what should we add to this typing judgment in order to be able to type check this location? So we might be tempted to extend this typing judgment into this one because we need a type for this location. So the first attempt is, why do we not just add this store directly? Then if this expression is location L, we could go back to this store and get the value in the memory cell associated with this location L, and then get its type. Let's say this value V has a type A, then this location L would have a type reference A. So that's the idea. But it turns out that this attempt fails, and let me explain why. So let me summarize the problem. The problem is the previous typing judgment, gamma turnstile expression A, this is clearly inadequate. We have to add something new. So our first attempt is, why don't we add store directly here? But I said this typing judgment has some problem. So let me show you why. Suppose that we are trying to decide the type of this location L. So what is the type of this location L? In order to decide the type of location L, so currently, let's say location L is pointing to this memory cell, and it has value V. So to decide the type of the location L, we check the value under this store psi. Let's say psi is mapping location L to value V. Then the idea is, why don't we decide the type of value V? If this has type A, then we could assign ref A to this location L. So everything looks fine, except that we may never be able to complete the construction of this typing derivation. And the reason is, in general, this value V itself might contain location L. So in other words, location L is currently pointing to this value V, but inside the value V, you might have a location L. Again, in this case, if you keep trying to complete this typing derivation, eventually you will end up with the same question that you started with. Because this value V contains location L, so at some point you will encounter the same location L, so now you go back to the original problem. So this is the reason why this plan doesn't work. And we actually have seen an example of this circular reference previously when we were looking at the wrong answer of simulating integer array using mutable references. So in the wrong answer, we actually saw how to construct a value of this form, where this location L is found, this location itself is found in its value. So in that case, we will never be able to get the type of this location. So this doesn't work. So if you think about why this attempt fails, we realize that what we need is not this store itself, rather some sort of abstraction of the store. Intuitively, we don't need the actual content value v for this location L. We only need the type of this value v. But in some sense, this psi is more than necessary. We only need the type of this location L, but it contains everything, the value itself. So this observation leads to a new attempt. So previously we have a gamma turnstile expression E has type A, and now we are going to add something new, and this something new is store typing. So remember, store is lowercase psi, and it is a collection of location mapped to value v. So this is the store, but this is the store typing. So for store typing, capital psi is either empty or an existing store typing extended with L arrow A. So this time we only store the type of this location. So for instance, if L is pointing to some integer value, so here integer 3, then we would have store with L arrow 3, but store typing would have L arrow integer. We just store the type of this content, the content of this memory cell. So this is the typing judgment that we need in order to incorporate mutable references into our language. So this is the typing judgment. So with typing judgment, it's actually straightforward to develop the typing rules. So for example, the extension for this variable, lambda abstraction, and application, and unit. So this extension is straightforward, so let me skip it. The interesting cases are, what is the type of this reference, for example? Gamma, psi, this capital psi store typing with reference E. If expression E has a type A, then this would have a reference A. And similarly, if we have this bang expression E, we get the type of expression E, and this is supposed to be reference A, and then we assign type A. So again, this is not store, this is store typing. Not store, but it's store typing. This is store typing. And what about this assign E prime? It's going to have type unit if everything is okay. So expression E is going to have a type reference A, and then we expect expression E prime to be of type A. Then these two expressions live in harmony with each other, so we can assign type unit. And finally, what's the typing rule for location? In this case, it's just a matter of looking up the store typing. So for example, if a store typing has a mapping from location L to type A, then you just return ref A. So this thing means that if you go to the memory cell for this location L, you will find a value of type A. So therefore, location L is going to have type ref A. So this is the type system where we use this store typing. There remains one critical question, however, which is how do we obtain the store typing from store? In order to use this store typing, in order to use this new form of typing judgment, we have to have the store typing. And the store typing is derived from this store. It depends on this particular store. So we should be able to calculate store typing from given store. So in other words, if we are given some store like this one, we should be able to calculate the corresponding store typing. And in fact, our attempt may fail. For example, if this store is ill-formed, then we may not be able to obtain this store typing. So therefore, we should figure out how to calculate the store typing from given store. Now, the last question to address is, suppose that you have store something like L1 arrow value V1, L2 arrow value V2, Ln arrow Vn. Then how do we obtain store typing? Capital Psi. So how do we obtain L1 arrow type A1, L2 arrow A2, Ln arrow An? So the question is, given this store, how do we calculate this store typing? So a simple approach is to proceed from left to right. So that is, take a value V1, calculate its type A1, and then consider V2, calculate its type A2, and then we move on up until the last value Vn. If this one has a type An, we calculated the store typing like this one. So that sounds simple, except that this doesn't work. The reason that this approach where we just access these values sequentially, the reason that this approach doesn't work is we have value V1, we have value V2, we have value Vn. It may be that all these values are mutually dependent. For example, L1 is currently pointing to value V1. We might have L1 here, and we might have L1 here as well. In general, this value L1, location L1, may appear anywhere in any of these values. For the same reason, currently Ln is pointing to this value Vn. For the same reason, this location Ln might be found anywhere in any value. So if when we are trying to calculate the value the type of this value V1, we might see inside the value V1, we might actually encounter location Ln, which we have not considered yet. So this sequential approach doesn't work. What we need is, because of the potential mutual references inside all these values, we have to calculate all these values, all these types A1, A2 through An all at once. That's what our intuition says about how to calculate the store typing capital psi from store psi. So formally, we write in this way. How do we calculate the type given a store psi? How do we calculate its store typing capital psi? So first of all, so you can think of this one as input to the problem. You are given a store, and you can think of it as output. How do we calculate the store typing from this store? So this is input, and this is output. So first, we notice that the domain of this input and this output is identical. So what I'm saying is, store psi is mapping L1 through Ln. Similarly, store typing capital psi should also map location L1 through Ln. You don't want to have another location, for example, Ln plus 1. So you don't want to add an extra location Ln plus 1 here, which is unnecessary. So formally, we could require that domain of psi be equal to domain of capital psi. And then we have to calculate the type of all these values simultaneously, all at once. So formally, we can write it as under this store typing capital psi, the value, let's say currently store psi is mapping L to value V, then this is going to be value V. And in the answer, so this is the answer, L is sending, in the answer, this store typing, L is mapped to type A, then you have A here. So we write the capital psi L. So this is A. But the important point here is that it's kind of recursive. You have to employ recursive reasoning here because, again, so this is output. So you start with this input store, and you'd like to find out this store typing, but in the course of figuring out this store typing, you have to use it here. It's recursive, but this makes sense because you have to find out the type of all these values all at once. So given these values v1 through vn, you have to find out their types all at once. Because of the potential presence of a mutual recursion between all these values. So it turns out that in the course of calculating the store typing capital psi, you have to rely on some sort of recursive reasoning. So you assume that you pretend that you have figured out the store typing, and then you make sure that under the store typing capital psi, everything works okay. Then you confirm that the store typing is indeed the solution. So I guess the point I'm trying to make here is this rule looks innocent, but it involves some element of recursion, which makes perfect sense because you have to calculate the type of all these values all at once, simultaneously. So there should be some element of recursion here.